Hello, my esteemed viewers. You're welcome to Medical Science Lecture Room. In case you're around new to this channel, please hit the subscription button, turn on your notification bell so that once new videos are made, you'll be first to be notified. Again, like and subscribe to this channel. Once again, my name is Dr. Godwin Obono. Today, I'll be discussing with you on a very important topic called the zeros of a polynomial. What do we refer to as the zeros of a polynomial? Let's quickly discuss it. Now, zeros of a polynomial, when we say zeros of a polynomial, we are referring to simply roots of that polynomial. What are those numbers? What are those numbers that if you substitute in that polynomial, it will become zero? For instance, if I have a polynomial f of x equal to x squared minus 1. If I have a polynomial, let's start with the simple ones. If I have a polynomial f of x equal to x squared minus 1, and somebody now say, what are the zeros of this polynomial? What that person, the examiner is asking for are those numbers which when substituted in this expression, it will become zero. That's what it means by what we mean by zeros of a polynomial. Zeros of a polynomial is the same thing as the root of what that expression. Just like in your quadratic equation, of course, is a polynomial with degree 2. So when we say the root of a quadratic equation, we are simply referring to what the zeros of a quadratic equation. Now, if I have, for instance, x squared minus 1, and I want to find the zeros of x squared minus 1, I'll simply say, I've been asking myself, what are the numbers which, if they are substituted here, this expression will become what? Zero. Now, let's say x equal to 1, for example. If x is equal to 1, we will try to substitute x equal to 1 in that expression. So we have f of 1. And that f of 1, remember that we were given f of x. Now, in this case, we want to substitute x equal to 1. It becomes f of 1. It means wherever we have x, we should replace with what? 1. This becomes 1 raised to power 2 minus 1. Of course, you know this will become what? 0. Where 1 raised to power 2, of course, is 1. 1 minus 1, that becomes what? 0. You can see, therefore, we can say that x equal to 1 is what? A root of this equation, or is a 0 of that equation. Remember, I said the 0 of any equation refers to numbers or refers to roots of that equation. It refers to numbers which, when substituted, the expression will turn to 0. As you can see in this case, x equal to 1 is a root of that equation. X equal to 1 is a 0 of that equation, because when substituted, the x squared minus 1 are turned towards 0. Again, let's try another one. If we say x equal to minus 1, x equal to minus 1, the first one is x equal to plus 1. Now let's try x equal to minus 1. That will be f of minus 1 equal to, we'll try to substitute here. That will be minus 1 raised to power 2 minus 1. And that, of course, will give us 1 minus 1, and that turn towards 0. That again tells us that x equal to minus 1 is the root of this equation. X equal to minus 1 is the zeros of this equation. I want again to remind you that x squared, because this polynomial has power 2, it has power 2. It tells us that the root of this equation, if this expression is factorizable to linear root, it therefore means that those roots must be 2, because the power here is what? 2. If the power here was 3, then, and all the factors, or rather all the factors are linear, we equally will expect 3 what? Roots. But in this case, we have what? X equal to, we have x equal to 1, x equal to what? Minus 1. These are the two numbers that represent the zeros or the roots of this equation. Let's try another. X equal to 3. Let's say x equal to 2. We try to substitute. That's f of 2. That will give us 2 raised to power 2 minus 1. Of course, this will be 4 minus 1. This is equal to 3. You can see that f of 2 will give us what? A remainder of what? 3. Remember that when we say f of 1, what we are looking for is what? A remainder. So when we say the remainder is 0, once the remainder is 0, if the remainder is 0, it means that that value of x for which the remainder turns to 0 is the root of that equation. That same value is a 0 of that equation. But when the r is not, when the remainder is not equal to 0, that value you substituted for which the expression did not turn to 0 is not a root of the equation, it's not a 0 of that equation. Let me take that to relate it to this. You can see when we substituted what x equal to x equal to 1, therefore we had the remainder to be what? 0. And because the remainder was 0, then we say x equal to 1 is what? When I say x equal to 1 is what? A root of that equation. Again, if I move this one, I move it to the left hand side, because of course here is plus 1. If I transfer it to the left hand side, it becomes what? X minus 1. We now say x minus 1 is what? A factor. Please get the distinction, the difference. I've mentioned here root, I've mentioned zeros. Zeros is the same thing as root of the equation. Now I've equally mentioned remainder. The remainder is the pointer to what? The remainder tells us that what was substituted is either a root or it is not a root. If the remainder is 0, what was used to substitute would become what? A root. It will become what? A 0. But if remainder is not 0, what he used, the value of x that was used to substitute, therefore will not be what? Considered as what? Root of that equation. For instance, in the case where we say x equal to 2, when we substituted, you see that the remainder, we found the remainder to be what? 3. Because the remainder is 3, it is not 0. It therefore means that it means that 2 is not what? A root of that expression. That's what it means. And again, when we say x equal to 1, you notice we have the remainder 0. And we say because the remainder is 0, 1 is the root of the equation. When I move this 1 to the left hand side, it now becomes what? X minus 1. Therefore, x minus 1 becomes what? A factor. When we say x equal to minus 2, remember the remainder, when we say x equal to minus 1, remember the remainder was equal to 0. And because the remainder is 0, if you transfer, because the remainder is 0, it means that x equal to minus 1 is a root of that equation. Or x equal to minus 1 is a 0 of that equation, x squared minus 1. Now, if I move minus 1 to the left hand side, it becomes x plus 1. It therefore means x plus 1 is what? A factor. Now, factor is simply when you move that root to the other side so that you now have a binomial. Now, in the case where we say let x equal to 2, remember that the remainder was what? Our remainder was 3. And because the remainder is 3, it therefore means that this 2 is not a root. It means that this 2 is not a 0 of that expression. If I move this 2 to the left hand side, it becomes what? X minus 2. It also tells us that x minus 2 is not a factor. It's not a factor of that expression. For x minus 2 not to be a factor, it means that x minus 2 cannot divide x squared minus 1, given a remainder of what? 0. Very important topic, because this topic it's a central topic in that it can lead you to it can lead you to other simultaneous equation. So, which is why I want you to have understanding of this. Now, look at this question. They say given f of x equal to x raised to power 4 minus 3x raised to power 3 plus 5x raised to power 2 minus x. The question is find f of 1, f of 2, f of 1 minus f of 2. Now, solution. Remember, we've been given f of x is equal to x raised to power 4 minus 3x raised to power 3 plus 5x raised to power 2 minus x. Now, the request, we're asked to find what? F of 1. F of 1 means that in place of x, we should what? Substitute 1. And that will give us 1 raised to power 4 here minus 3 into what? 1 raised to power 3 plus 5 into 1 raised to power 2 minus 1. Remember, everywhere, wherever we have x, we have to substitute that the value of what? 1. So in this case, so 1 raised to power 4, of course, that will be what? 1. Then 1 raised to power 3 is 1 times this. That will give us what? Minus 3. And then we have 1 raised to power 2. That, of course, is 1. 1 times this will give us plus 5. And then minus 1. Simply, we say 1 minus 3. That's minus 2. Minus 2 plus 5. That, of course, will be what? 3. And then 3 minus 1. That, of course, will be what? 2. You see that f of 1 is equal to 2. F of 1 is equal to 2. Now, if f of 1 is equal to 2, If therefore this tells us, it means that the remainder is equal to 2. Another way of putting it, it means that the remainder of what? It therefore means that when we are saying that, because this f of 1 is the same thing as a remainder, when a particular thing, a particular expression divides this. And what is that expression? If I move this, if I move this 2, because we are saying that when x is equal to 2, our remainder is when x is equal to 1, when x is equal to 1, we say the remainder is 2. This tells us that this x equal to 1, of course, is not a root. X equal to 1 is not what? A root, because it is not dividing that thing without any remainder. So if I move this 1 to the other side, it becomes x minus 1. That now tells us that when x minus 1 divides this using the long division method, the remainder must be what? 2. You can prove it. If you use the long division method, I have a video on how to divide a polynomial using the long division method. If you apply that with x minus 1, you will notice that what you will have will be what? The remainder of what? 2. But instead of going through that process of having to use the long division method, that's going to be lengthy. So you just use the remainders. This is what we call the remainders theory. And then with that, you'll be able to do what? Get the remainder straight up. You'll be able to get the remainder, and it's simple as that. Now let's quickly take the second one. We're asked to find f of 2. F of 2. This again means we have to substitute anywhere we find x. Let us substitute what? 2. Now that will be equal to, right there, that will be what? 2 to the power of 4. Remember, here we have x raised to the power 4, so we're going to have 2 raised to the power 4. Now minus 3. 2 is the x raised to the power 3 plus 5. The x here has to be raised to the power what? 2, then minus 2. And with this, we can ask ourselves, what is the value of 2 raised to the power 4? 2 raised to the power 4, of course, you know, that will be 16. 2 times, that's 2 times 2 times 2 times 2, of course. This is 4, this is 8, that's 16. You have 16, and this, of course, 2 into it, that will be 8. 8 times 3, that will be minus 24. And then you have 4, that will be 20. 4 times 5, 20, and then minus 2. Minus 2. So 16 minus this, of course, that will give us, so 16 minus 24, that will be minus 8. Minus 8 plus 20, that will be what? Plus 12. 12 minus, that will be 10. So we're going to have f of 2 to be equal to what? 10. Now finally, the third question says we should find what? F of 1 minus f of 2. What is f of 1? We got the value of f of 1 as 2. That will be 2 minus f of 2. The answer we got was 10. So 2 minus 10, of course, that will be minus 8. So that will be the final answer. You see, so this is simply the application of zeros of what? A polynomial. Again, just to recap, that is, the zeros of a polynomial refers to values of x for which the expression turns to 0. The variable x, whatever you substitute in its place, and the answer, the expression turns to 0, therefore means that those values represent what? The zeros, or the root of what? That expression. Remember, when you plot a quadratic graph, you notice we always say the root of that equation from the graph is when the graph cuts the x-axis. Now in this case, when the graph cuts the x-axis, when you read it, those 2 points, usually there are 2 points, because a quadratic equation has a degree 2, so it has to be 2 points, and those 2 points represent the root of what? That quadratic word expression. It means that at those very 2 points, when you read those values and substitute in that expression the quadratic function, the remainder will be what? 0. That's what that is simply telling you. So I want to believe you have understanding of what the zeros of a polynomial is. Very important. You need to have understanding of what the zeros of a... Now again, I have always recommended you to to go for other videos. I've done videos on division of polynomial, addition, subtraction, multiplication of a polynomial, remainders theory, and now today it's the case of what zeros of a polynomial. I equally have a video on factorization of what polynomial. Please look for all of these videos so that you make maximum benefit